Following is a video for finding the sum to n terms of the harmonic series. The harmonic series is defined as Sn is equal to 1 by A plus 1 by A plus D plus 1 by A plus 2D plus and so on 1 by A plus n minus 1 into D. Each term in the harmonic series is a reciprocal of the term in the arithmetic progression. This is defined as, using summation notation, 0 less than equal to I less than equal to n minus 1 Ti, where Ti is equal to 1 by A plus ID. Now we proceed as follows. In order to determine Sn, we need to determine summation I times Ti. Now we have Sn is equal to summation 0 less than equal to I less than equal to n minus 1 Ti is equal to summation 0 less than equal to I less than equal to n minus 1 by A plus Id. This is equal to summation 0 less than equal to I less than equal to n minus 1 by A times 1 minus ID by A plus ID. Therefore, we will have A times Sn is equal to summation 0 less than equal to I less than equal to n minus 1 minus D times summation 0 less than equal to I less than equal to n minus 1 I times Ti. Therefore, we will have D into summation 0 less than equal to I less than equal to n minus 1 I times Ti will be equal to n minus A times Sn, or summation 0 less than equal to I less than equal to n minus 1 I times Ti is equal to n minus A times Sn whole divided by D. We are interested only now up to sum to n minus 1 terms or Sn minus 1. Since we know that Sn is equal to Sn minus 1 minus Tn minus 1, sorry, Sn minus, sorry, since we know that Sn minus 1 is equal to Sn minus Tn minus 1, therefore we will have summation 0 less than equal to I less than equal to n minus 2 I times ti. Note that here we are only, I'm considering only up to n minus 2 or n minus 1 terms, because that is what must be substituted in order to find Sn. N minus will be equal to n minus 1 minus a times Sn minus Tn minus 1 whole divided by d. This is the first part for summation iti up to n minus 2 terms. Now we determine the sum Sn by making use of the following relation. For any harmonic progression, we have Ti minus Ti plus 1 is equal to d times Ti plus 1. Likewise, we have Ti plus 1 minus Ti plus 2 is equal to d times Ti plus 1 Ti plus 2. So Ti minus Ti plus 1 by Ti plus 1 minus Ti plus 2 is equal to d times Ti plus 1 by d times Ti plus 1 Ti plus 2 equal to Ti by Ti plus 2. So this ratio we have here. Now for the harmonic series itself, more generally we will have Ti is an intermediate term between T0 and Tn minus 1 with T0 inclusive but excluding Tn minus 1. Then more generally we will have T0 minus Ti by Ti minus Tn minus 1 is equal to I times T0 by n minus I plus 1 whole times T n minus 1. Or we will have cross multiplying T0 minus Tn Ti Ti times n minus I plus 1 Tn minus 1 is equal to Ti minus Tn minus 1 times into I times T0. Expanding it, we will have n minus I plus 1 T0 Tn minus 1 minus n minus I plus 1 Tn minus 1 Ti is equal to I times T naught T Ti minus I times T naught T n minus 1. We observe that T naught Tn minus 1 occurs on both sides, transferring this to this side and this to the left, right? And Ti occurs here, so making the transfer we will have I plus n minus I plus 1 T naught Tn minus 1 is equal to I times T naught Ti plus n minus I plus 1 Tn minus 1 Ti, or n minus 1 times, which implies T naught Tn minus 1 is equal to n minus 1 times Ti plus T naught minus Tn minus 1 I times Ti. This is the expression. Now we take summation on both sides of this expression. Summation over I up to n minus 2. Since in that expression up to n minus 2 only, otherwise the denominator will become 0. In the expression we have the expression T naught, earlier expression, by Ti minus Tn n minus 1. I can range only up to n minus 2, otherwise the value of the denominator will become 0. Now the equation that we have derived just now, if we take the summation on both sides, we will have summation 0 less than equal to I less than equal to n minus 2 n minus 1 times T naught Tn minus 1 is equal to summation over 0 less than equal to I less than equal to n minus 2 n minus 1 times Tn minus 1 Ti plus summation over 0 less than equal to I less than equal to n minus 2 T naught minus Tn minus 1 into I times Ti. Observe that there are only n minus 1 terms here. Therefore, we will have n minus 1 into n minus 1 times T naught Tn minus 1 is equal to n minus 1 times Tn minus 1 times summation Ti up to n minus 2, 0 to I equal to n minus 2 will be n minus 1 terms, that is Sn minus 1, which is Sn minus Tn minus 1 plus T naught minus Tn into n minus 1 minus a times Sn minus Tn minus 1 whole divided by d. So gathering all the terms involving Sn on one side and the other terms on the other side, we will have just one step before that is n minus 1 square T naught Tn minus 1 is equal. This is a simplification step. N minus 1 times Tn minus 1 Sn minus n minus 1 times Tn minus 1 square plus T naught minus Tn minus 1 into n minus 1 by d minus a times T naught minus Tn minus a times T naught minus Tn minus 1 Tn minus 1 times Sn by d plus T naught minus Tn minus 1 into Tn minus 1 by d. So gathering all the terms involving Sn on one side and the remaining terms on the other side, transferring the remaining terms on the other side, we will have n minus 1 times Tn minus 1 minus a times T naught minus Tn minus 1 by d whole times Sn is equal to n minus 1 square T naught Tn minus 1 plus n minus 1 into Tn minus 1 square minus T naught minus Tn minus 1 times n minus 1 plus Tn minus 1 whole divided by d. Which gives us that the Sn is the ratio of nothing but the right hand side by this factor. So this gives us Sn is equal to n minus 1 square T naught Tn minus 1 plus n minus 1 times Tn minus 1 square minus T naught minus Tn minus 1 times n minus 1 plus Tn minus 1 whole divided by d. This is in the numerator. Whole thing divided by n minus 1 Tn minus 1 minus a times T naught minus Tn minus 1 by d. This in the denominator. This is T naught. Now this derivation is performed using under the assumption that this is the value Ti is greater than Ti plus 1. That is, the series decreases when we take T naught minus Ti by Ti minus Ti plus 1 as the ratio there. It is under the assumption that Ti is greater than Ti plus 1. Two possibilities arise: either Ti is greater than Ti plus 1 when we take 1 by a plus id, or Ti is less than Ti plus 1. The derivation for the case Ti is less than Ti plus 1 can be performed along similar lines. But now we will just have to so this is the ratio. This is the sum to in terms of the harmonic series. If given the value of n, T naught is equal to 1 by a, Tn minus 1 is 1 by a plus n minus 1 into d. So a and d are known, n is known. Sum to n terms of the series is also known.